Ever bitten into a lemon and felt that sour zing that makes your face pucker up? That intense sensation is a direct result of the acid present in the lemon. It's a powerful and immediate reaction, a testament to the chemical properties at play. That's an acid in action. Acids are substances that donate hydrogen ions, and this donation is what gives them their characteristic sour taste and the ability to react with other materials. In the lab, we can observe these reactions with indicators that change color in the presence of an acid. Or noticed how soap feels slippery when you're washing your hands. That smooth, almost slimy texture is a key characteristic of bases. That's a base at work. Bases, also known as alkaline substances, accept hydrogen ions. This acceptance is what gives them their slippery feel and their ability to neutralize acids. Just like acids, bases can be identified using pH indicators. Acids and bases aren't just for scientists in white coats and laboratories. They're fundamental components of the world around you, playing crucial roles in your daily life. From the foods you eat to the products you use, acids and bases are constantly interacting. From orange juice at breakfast, citric acid, which provides a refreshing start to your day, to vinegar on your salad, acetic acid, acids give foods their tangy flavor, adding zest and complexity to your meals. They're responsible for the sourness in many fruits and fermented products. Bases are just as common. They are essential components in many household products. Baking soda in cookies, which helps them rise and achieve that perfect fluffy texture, or the cleaners under your sink, are all bases. These cleaners utilize the properties of bases to break down grease and grime, making them effective cleaning agents. They feel slippery and often taste bitter, though never taste cleaning products. This is because many bases are caustic and can be harmful if ingested. Even your car battery uses a strong acid, sulfuric acid, to generate the electricity needed to start your engine. And antacids you take for heartburn are bases, designed to neutralize excess stomach acid and provide relief. The soil in your garden, its acidity or alkalinity affects the growth of your plants. The rain outside, which can be affected by acid rain. Even your own stomach. Acids and bases are at work, constantly influencing the chemical processes around us and within us. Understanding them helps you see the hidden chemistry in everyday life, revealing the science behind the simplest of actions and observations. So, let's dive in and discover what makes something an acid or a base, exploring their properties and how they interact with each other. By the end, you'll spot the science in a glass of soda, understanding the role of carbonic acid in creating those delightful bubbles, or a bar of soap, recognizing the alkaline compounds that enable it to cleanse and emulsify dirt and oils. Ready? Let's get started on this exciting journey into the world of acids and bases. What's the secret behind acids? What gives them their unique properties and makes them so reactive? It's all about hydrogen ions. These tiny particles, carrying a positive charge, are the key to understanding acidity. They dictate how acids behave and interact with other substances. When an acid dissolves in water, a fascinating process unfolds at the molecular level. It releases hydrogen ions, tiny charged particles. This release is what defines an acid's behavior and its ability to react with other substances. The more readily it releases these ions, the stronger its acidic properties. The more hydrogen ions released, the more pronounced the acid's effects will be, the stronger the acid. This strength is directly proportional to the concentration of hydrogen ions in the solution. Vinegar, for example, a common household item, contains acetic acid, which gives away some hydrogen ions in water. This release contributes to its characteristic sour taste and its ability to act as a mild cleaning agent. That's what makes lemons sour, that distinctive tang that awakens your taste buds. And green apples tart. These fruits owe their characteristic flavors to the presence of acids. Acids can even react with metals, leading to some visually striking chemical reactions, causing fizzing and bubbling, a telltale sign of hydrogen gas being released. This reaction demonstrates the power of acids to break down and transform materials. Not all acids are equal. Their strength varies greatly depending on their chemical structure. Strong acids like stomach acid release lots of hydrogen ions, creating a highly reactive environment, while weak acids like vinegar release fewer, resulting in a milder effect. That's why you can eat vinegar, enjoying its flavor without harm, but not drink strong acids. Their concentrated power can cause severe damage. The strength of an acid, a crucial factor in determining its reactivity, depends on how many hydrogen ions it sets free. This release is a fundamental aspect of their chemical behavior. So, next time you taste something sour, remember, it's not just a flavor sensation. Molecules are breaking apart, undergoing a chemical transformation, releasing hydrogen ions right onto your tongue, triggering a cascade of signals. Your taste buds are detecting a chemical reaction. They are the sensors that translate the presence of hydrogen ions into the sensation of sourness. This ability to release hydrogen ions is what defines acids, setting them apart from other chemical compounds. It's their chemical superpower, enabling them to participate in a wide range of reactions. That's what sets acids apart in the world of chemistry, making them essential players in countless processes. And it's happening all around you every day, from the food you eat to the cleaning products you use. Acids are an integral part of our daily lives. So, we've talked about acids and their ability to donate hydrogen ions, but what about their counterparts? Well, bases do the opposite. They're like the welcoming committee for those hydrogen ions. They accept hydrogen ions directly, or they release hydroxide ions, which then go on to grab those hydrogen ions themselves. It's all about neutralizing the acid. When a base dissolves in water, it's like a chemical party starts. It produces hydroxide ions, those little scavengers ready to react. These hydroxide ions are great at grabbing hydrogen ions, forming water and neutralizing the solution. That's why bases are often called acid catchers. They're always on the lookout for those pesky hydrogen ions. Ever notice the slippery feel of soap? That's a base reacting with the oils on your skin, breaking them down and creating that characteristic slickness. It's turning those oils into soap, right there on your hands. This process is called saponification, a chemical reaction that's been used for centuries to make soap. Bases often taste bitter, a flavor that can be quite distinctive. Think of the taste of unsweetened cocoa or tonic water. That's the taste of a base at work. Now, strong bases, like sodium hydroxide, commonly found in drain cleaner, release A of hydroxide ions and are therefore very reactive. They need to be handled with care. On the other hand, weak bases, like baking soda, release fewer hydroxide ions and are gentle enough to be used in baking, or even in your toothpaste. The strength of a base is all about how eager it is to neutralize acids, how readily it accepts those hydrogen ions. Acids donate hydrogen ions, remember? And bases accept them, completing the chemical dance. They're chemical opposites, like yin and yang, constantly seeking balance. And when they meet, something special happens: neutralization. Remember, bases are everywhere around you. From your kitchen with baking soda to your cleaning supplies under the sink. They're the unsung heroes of everyday chemistry, working silently to keep things balanced. So next time you use soap to wash your hands or baking soda to bake a cake, you're using a base in action, witnessing its chemical properties firsthand. That's the magic of bases, working all around us. How do we measure how acidic or basic something is? With the pH scale. The pH scale runs from 0 to 14 and measures the concentration of hydrogen ions. A pH of 7 is neutral, like pure water. Below 7, it's an acid. The lower the number, the stronger the acid. Lemon juice is around pH 2, stomach acid even lower. Above 7, it's a base. The higher the number, the stronger the base. Baking soda solution is about pH 9, soap around 10, and drain cleaner can reach 14. The pH scale is used everywhere in farming, medicine, water treatment, and more. You can test pH with litmus paper or digital meters. Just dip and match the color. It's a simple tool for understanding the invisible world of acids and bases. Farmers, doctors, and scientists all rely on it. Even you can use it at home. The pH scale makes the chemistry of everyday life visible. It's your ruler for the world of acids and bases. Your kitchen is a science lab full of acids and bases. Vinegar and lemon juice are acids that tenderize meat and keep fruits from browning. Pickling uses acid to preserve food and keep bacteria away. Baking soda is a base that helps cakes and cookies rise by creating bubbles when mixed with acids. That's why your baked goods turn out fluffy. Even caramelizing onions can be sped up with a pinch of baking soda. Bases help break down sugars for that rich, sweet flavor. From tender meats to fluffy cakes, acids and bases are your secret kitchen tools. Every meal is a chemistry experiment. Next time you cook, notice the science at work. Acids and bases make your food tastier and your cooking more fun. Delicious chemistry right at home. Cleaning your house? Acids and bases are the secret weapons. Bases like those in oven cleaners and degreasers break down greasy messes through saponification. They turn fats and oils into soap-like molecules you can rinse away. Strong bases like sodium hydroxide dissolve tough clogs in drains. Acids like vinegar or citric acid tackle mineral stains. Think hard water spots or rust. The acid dissolves mineral deposits so you can wipe them away. Always choose the right cleaner base for grease, acid for minerals. Never mix cleaners. Combining acids and bases can be dangerous and even create toxic gases. Use one product at a time and follow directions. With a little science, you can clean smarter and safer. Chemistry keeps your home sparkling. Want to see acids and bases in action? Make a pH indicator with red cabbage. Boil chopped cabbage in water, then strain out the leaves. The liquid is your indicator. Pour it into cups and add household liquids like lemon juice, vinegar, baking soda solution, or soapy water. Watch the colors change. Pink for acids, purple for neutral, green or yellow for bases. You've just revealed the pH of everyday items with a simple kitchen experiment. It's science you can see. Try testing different things and see what colors you get. Chemistry is colorful and fun. Science is amazing, but safety comes first. Many household acids and bases are safe, but strong ones can burn skin or harm your eyes and lungs. Always have an adult present when using strong cleaners, and wear gloves and goggles. Work in a well-ventilated area. Never mix cleaning products. Some combinations can create toxic gases. If you spill a strong acid or base, rinse with lots of water and tell an adult. Use one product at a time, as directed. Stay safe so you can keep exploring science. Why learn about acids and bases? Because they shape your world. They help you cook, clean, and even understand your own body's chemistry. Knowing about them lets you make smarter choices every day. You'll know which cleaner to use, how to make fluffier cakes, and how to stay safe. Acids and bases affect the environment too, from acid rain to ocean health and farming. Understanding them connects you to big global issues. Science is about curiosity and asking questions. Now you know the secrets behind sour lemons and slippery soap. Keep exploring. There's always more to discover. Stay curious and let science lead the way.